Hi all, in this video we are going to see the concept of input buffering in compiler design. As you are aware, compiler is used to convert a high level language into a machine level language code. And in compiler design, lexical analyzer is the first phase which will convert the source code into token. Basically, it will read character by character for the conversion. While doing that, every character we have to use a single system call for each and every character. To avoid that, we are having the concept called as input buffering, and here the source code will be read in a large chunks into a memory buffer. So where the block of code will be read in a single system call itself. This is the advantage of using the input buffering instead of reading character by character. And now when we have a source code, the source code generally stored in the secondary memory. So during the execution only, it will be loaded into a primary memory. And how the source code will be read from the secondary memory to the primary memory, that only we are going to see now. So this is my source code. I am just having a source code int main, followed by I have just declared two variables, and where I am doing just the operation A equal to A plus B. And this source code gets stored in a secondary memory. So secondary memory generally have a block of code. And this instructions of the source code get stored in this secondary memory in a block. So for example, to work with, I have here int main, and then this, so this gets stored in the memory. So if I want to read the character one by one, basically I have two pointer. The first pointer is called as beginning pointer, and the second pointer is called as lookahead pointer, or it will be called as forward pointer. And when we read characters from the block of memory, the character get read one by one. So in the beginning of the block, we have the beginning pointer, and also we have the lookahead pointer. And the beginning pointer always be there in the beginning of the block. And the lookahead pointer will be moving in a forward direction. So now during the next read, the lookahead pointer will come here. And in the next character reading, the beginning pointer will be staying in the beginning, and the lookahead pointer will be coming here. And again, we have the next block to be read, or the next character in the block to be read. So now the lookahead pointer will be coming here. Whenever the lookahead pointer reaches an empty space or a special character from the lexeme, it will identify the character whatever it reads. So far it read I, N and T. So it will be identified as a token. And this get stored in the symbol table. The integer is a token, and which is nothing but a keyword. And after doing that, the lexical analyzer start to read the next character. So now what happens? The beginning pointer comes to the beginning of the next token, and the lookahead pointer starts to read the next token from the input. So until then, it will come here. After reading, it will read M, A, I, N, and once it is encountered a special character, it know that it is a token. So it gets stored in the symbol table main, which is nothing but a keyword. And after doing that, again your beginning pointer come to this location and the look ahead pointer again try to read the next character. So now this is again a special symbol and it will identify this is nothing but a symbol or it is a open bracket. So like that it will try to store or read one character at a time. So this is the way how it will be happen, and here the main limitation is while reading one character from the block we need one system call. So if our source code having some 10,000 lines of characters in the source code, we need to do the calling of 10,000 system calls. So to avoid this complexity only, we have the concept of input buffering. In input buffering, instead of reading character by character, we are going to read a block of code from the memory. So to read a block of code, one block of code, we need one system call. And the buffer size. So we have the secondary memory, and this secondary memory having a block of code, and this block of code just read and kept in the buffer. So the length of the buffer is equal to the length of the block in the memory. And again the same way we have two pointers, that is our beginning pointer and the look ahead pointer. Both will try to do the job instead of doing the character reading in the secondary memory. Now these will try to read the character from the buffer. So this will make the reduction of the system call and also the speed of reading your characters from the buffer. And there are two types of input buffering scheme. One is called as one buffer scheme and the next one is called as two buffer scheme. So now we will see how the one buffer scheme and the two buffer scheme is working. So one buffer. So now we have a single buffer which is the size of the disk block. So during the single buffer concept or a one buffer concept, a block of code from the secondary memory, a block of code from the secondary memory get read through a single system call and loaded inside the buffer. This is our buffer. So using a single system call, a block of code from the secondary memory is loaded inside the buffer. And similar with the two pointers, that is our beginning pointer and the look ahead pointer will do the job inside the buffer to convert these lexemes into tokens and update in the symbol table. And this has some limitation. The first one is when our input or the lexeme source code is greater than the size of the buffer. So as you know, I want to load int main. So this is my source code. This I want to load inside the buffer. But according to the storage, I'm not able to load the entire length of the lexeme. Instead of that, the part of the lexeme only get loaded in the memory. So my instruction is incomplete. That is a problem. So what happens? So after reading, it will come here my look ahead pointer. I need to read the next character n. But I have a single buffer. So what it will happen? It will, the new set of instruction get override in the memory. So when it get override, my token is not able to recognize because MAI is here and n is here. So I'm not able to get the proper token because my token is incomplete, that is MAI is here, which get now override with a new set of character inside my buffer. So I have an incomplete token, and also the problem is I have override the previous instructions with a new instruction. So still I am not able to identify my token as a main. And to avoid this limitation, we have a two buffer concept. In the two buffer, initially we have two buffers which are empty, and every buffer having a size of the size equal to the disk block. And now what happened? The first set of instruction, like our previous single buffer, the first set of instruction get loaded here. And now our beginning pointer is here and our look ahead pointer is here. So when the look ahead pointer reaches the end of the buffer, immediately the next set of instructions get loaded into the second buffer. This is our first buffer and this is our second buffer. So once the look ahead pointer reaches the end of the buffer, every time the look ahead pointer moving, it will check whether it is a character or it is an empty space or it is a special symbol or it is the end of the buffer. If it reaches the end of the buffer, the second buffer get loaded with the instruction. So now you see here the beginning pointer is here and the look ahead pointer is here, and after the next iteration the look ahead pointer comes here. It will identify it is a special symbol, so the token whatever it read is a main. It identify it is a keyword and it will be stored in the symbol table. So now there is a problem, that is the look ahead pointer has to do two checking. That is, it has to check every character is a character or a symbol or a empty space, and also it has to check whether it is a end of the buffer. So two checking it has to do for every character. So to avoid that, at the end of the buffer, a special symbol called as sentinel has been added. So when it reaches here itself, it will know that it is the end of the buffer. So your second buffer get loaded with the data. So here we have the forward pointer or our look ahead pointer. The look ahead pointer will be incrementing. So first case, when the look ahead pointer reaches end of the first buffer, what happens? The second buffer get loaded with the data. We reach the end of the first buffer, so our second buffer get loaded with the data and the look ahead pointer move to the second buffer. Similarly, you assume now our look ahead pointer is at the end of the second buffer. That is a second case. The look ahead pointer is the end of the second buffer. So what will happen? Our first buffer get reloaded with the data and the look ahead pointer moves to the beginning of the first buffer. So like that it will repeat with the two buffer scheme to avoid the one buffer scheme's limitation. So now we will just go with here. So this will help you to understand how it will be working. So when the first set of instructions loaded in the first buffer, the beginning pointer and the forward pointer starts to read a character, and when it reaches the end of the buffer by identifying the special character EOF as a sentinel, immediately the second buffer get loaded with the new data. The next set of block from the secondary memory, it get loaded in the second buffer. So our look ahead pointer will moving here and the beginning pointer will be available here. And when it reaches here, it identified as a token, then it will moving. And now the location pointer or the look ahead pointer reaches to the end of the instruction. So that time what it will do, it will load the first buffer. The first buffer get loaded and the beginning pointer will come here and the look ahead pointer also come here. Now once it reaches the end of the first buffer, immediately the second buffer get loaded and the look ahead pointer will move to the second buffer. I hope now you have an understanding of how the input buffer is working. So input buffer, and it is using a two pointer, begin pointer and the look ahead pointer. As you know, when you read characters or the inputs from the secondary memory, one system call per character to read each and every input. So this demonstration we have seen already. And the input buffering will read a block of code into a buffer. So one system read call is enough to read n characters into a single buffer. And there are two schemes, one buffer scheme and two buffer scheme. So when our lexeme is longer than the buffer size, the lexeme will cross the buffer boundary. And also if you want to load the next set of character or the next set of instruction, the buffer get overrides with the new data. And we are having a two buffer scheme to overcome the limitation. We are having two buffers with the size of n. And here the look ahead pointer moves toward the end of the first half. The second half will be filled with the character. Like that, if the look ahead buffer moves to the end of the second buffer, the first buffer will loaded with the data. So you want to read n characters into a buffer, you need only one system call from the memory. And here we have a problem. Every character you read, you have to do two tests. One, you have to check whether it is a buffer end or which character you are doing or reading. So to avoid that, we are using a special character called as EOF, which is called as sentinel character. So when we reach the sentinel character, we can identify you reach the end of the buffer. And you see here, this is a forward pointer, and the forward pointer encountered a sentinel character. If the forward pointer is end of the first buffer, means it will load the data in the second buffer, and the forward pointer move to the beginning of the second buffer. The same case, if the forward pointer is at the end of the second buffer, then it will load the character in the first buffer and move to the beginning of the first buffer. In any other case, it will be checked for the other characters, or it reach the end of your instruction. It may terminate the lexical analysis to mark it it's the end of the input. You have read all the characters from the source code. I hope you have an idea of how the input buffering is working with the one buffer scheme and the two buffer scheme.